All right, welcome. This is the Chapter 6 review. I will not be doing the entire review with you, but I will go over a couple of questions on each page just to make sure you get the idea of what to do. So on the first page, make sure you read the directions just as you would on the test. The first thing we're going to do is first just decide, is it linear or exponential? So I'll be putting that next to an A. Then what we're going to do is identify B and then M or G, just depending if it's linear or exponential. And then we're going to write the function. So in your flip books, if you look in the top left-hand corner, unfortunately that's something I can't show with this feature, is the flip book. But in the top left, we have written linear, and then underneath that is exponential. So just a reminder, our equations that we're using for linear are y equals mx plus b, and for exponential it's y equals b times g to the x power. So the first thing I'm going to do, we'll just kind of go through and pick some random ones on the first page. So I'm going to start with just the first one. So when I look at the problem, the first thing I notice is it's exponential. So, part A, I would just put an E for exponential. Then part B, I need to identify B and then G since it's exponential. And B is going to be this point right here. So B is 4. And then I want to see how is it growing. So this is going down. So they're definitely multiplied by a fraction. And this is what you would also do on the mile marker on that bottom section. So what I need to do is maybe make a little table. And I need to find some points that are in order that I could recognize. So again, I've already recognized the 0, 4, but I also know I can see this is a clear point and this is a clear point. So when I look at them, I know that -3 is 8, and that 0 is 4, and that 1 is 2. And from there, hopefully what I can see is, what am I multiplying to get from 8 to 4, 4 to 2? And remember, if you can't see what you're multiplying by, you can take a y. So for instance, I could take 4, and I could divide it by the previous y, which would be 8, and that's just 1/2. So in this case, G is going to be 1/2. And now I can write the equation. So it's going to be y equals, you could do f of x, and then b times g. I'm going to put my g in parentheses, and then you got your x as your exponent. So there's number 1. Let's take a look, for instance, at number 5. We're just going to maybe do a little diagonal. So on 5, I can immediately see just from the shape of it that this is linear. So as far as A goes, it's going to be linear. And then B, I need to figure out my y-intercept. So again, it happens to be 4, so B is 4. And then I'm going to need my M. So in linear, when you have a graph, you don't need to make a table. You just need to find some easy points. So here's an easy point, here's an easy point, and see your rise and your run. So to get, from this point to this point, I am going up one spot, but if you notice the scale, it goes from 4 to 6, so I'm actually rising 2. And then I'm running over 1. So my slope is 2 over 1, but you could also just put 2. So then for C, what I'm going to do is write my equation. Y equals M, that's the 2, x plus 4. All right, let's do one more. Let's take a look at, let's do number 9, for instance. So again, I can see just by the shape of it that it is exponential. So as far as A goes, I'm going to put an E for exponential. Then I need to find my y-intercept. That is this point right here. It's 100. And then I'm going to need to see what it is growing by. So again, this is what I would do on the mile marker. I'm going to make my table. And I can see 0, 100 is a clear point. It's kind of hard to tell, so I'm going to point this out that that's 400. And then I got this point down here. So when x is -1, I have y being 400. When x is 0, that doesn't really look like 400, does it? Let's fix that. When x is 0, y is 100. And when x is 1, my y is by the scale that is 25. So what am I multiplying to get from here to here to here? Well, it looks like we're dividing by 4, but remember, I need to put what we're multiplying by. So if you can't see, you just take a fraction. So you take a y. So in this case, to find g, I'm going to take 100. And I'm going to divide it by the previous y, which is 400. And then I'm just going to simplify that fraction. And that can happen really easily by these zeros canceling out. And when I'm done, there's my g. It's 1/4. So I can divide by 4 to get the numbers. But when I write my g, it needs to be what I'm multiplying by. So 1/4. Now I'm ready for my equation, c. So this time I'm going to write f of x, because that was always an option. It's going to be b, 100, times 1/4, which I'm going to put in parentheses, and to the x power. So just going through some of the other ones, if you need some clear points, let me mark them for you as you are doing your graph. So number 7, some easy points to note is this point. Whoops, sorry, didn't show up. That's 1/6. And another really easy point to note is this one of 2/12. And then moving up, again, you can always pause. Some easy points. Well, these are all easy points. Okay, so you can use any of those. All right, let's move on to the next page. So in this problem, okay, so on the second page, you've got a couple word problems here. I'm going to go through one of them, and then you're going to have to walk through the other ones. So why don't we jump to number 12? So how we do number 12 is similar to how you might do 10 or 11, but 12 is kind of a bigger problem. And you had something similar to this on that content check. So we have a situation where you have bacteria. It starts with a population of 30, and then after 1 hour, it increases to 75. So we're going to look at this in two situations. One, we're going to, look at it in a linear situation, but then we're going to come back and we're going to look at it in an exponential equation. So in linear, just remember that we've got y equals mx plus b. So we will need our starting amount, and that is going to be the 30 cells. And then we're going to need our m. So what we want to do is, remember, m is when you add. So we want to look at how did you go from 30 adding y's to 75, and that is a difference of 45. So that's our m. So the first thing I'm going to do is now write my equation for this one. So y equals m. There's your 45x plus b. And now we're going to do the same thing for exponential. So we're using the equation y equals b times g to the x. Our starting amount is still 30, but remember, g is what they multiply by. So this time what I want to check out is, what did I multiply by to make 30 become 75? So in your flip book, in the bottom left-hand corner, we talked about growth factor, and we added the other day that to find g, that you can take the new amount and divide it by the old amount. So the new amount is 75 and the old amount is 30. And if you turn on your calculator and you take 75 divided by 30, you can only do this one way. You can't do 30 divided by 75. You're going to get your growth factor of 2.5. So now I'm ready to write the equation. So switch colors here. The equation is going to be y equals your b, which is 30, and then 2.5, I'm going to put that in parentheses, to the x power. So now what we're going to do is we're going to use our two equations to answer the questions. So we're going to start with the linear. Okay, so for the linear, we want to use this equation up here. So we want to predict what the population is after 24 hours. So I'm going to take that 24 and I'm going to put it in for x. So it'll be y equals 45 times 24, and I'll be adding 30. Order of operations, you would do your, you could just type this in your calculator, but you would do your multiplying first. When you're done, you should get 1,110, and that's how much bacteria we should have. So now we're going to do this for the exponential problem. So when we do exponential, we're going to be using this equation over here. So I'll have y equals 30 and then 2.5, and this time in for x, I'll put the 24. So when you do that, you actually get a really big number on your calculator. If something shows up like this, just let me know, but it probably says 1.06, because I've already changed it, and I think there's probably an E. It means times 10 to the 11th power. Okay? So if you're not sure what that answer means and you type it on your calculator, call me over and I will be happy to assist. So kind of just backtracking to the other ones, you're going to have to tell me, is it linear or is it exponential? Then you're going to write your equation, and then you're going to use that equation to predict the population in 2020. Do not put 2020 in. If the initial year is 1990 and you're going to 2020, that's going to be 30 years later, okay? And then when you do number 11, again, is it linear or exponential? You're going to write the equation. Again, you need these to write the equation. And then determine when the altitude will be 10,000 feet. So this in your equation will be y. So when you have your equation, you're not going to replace your x with 10,000. You're going to replace your y with 10,000. Okay? So a little sneaky on that one. All right, we are going to be moving on to the next page. All right, so I want to talk to you about 13. So you're tracking the population of a herd of bison. And, sorry, you can't even see the whole thing. Just a second. And we're going to write an exponential equation about this. So again, we're going to be using the equation y equals b times g to the x. And my b is right here. It's 100. And now I need to figure out what g is. So remember, in order to find g, your x's have to go up by a constant amount. And in order to be successful about finding g, I want you to notice that some of these numbers are in bold, because we've always done it where you have, an x and then the one right after it. So this x is 3 and this x is 4. So I'm going to choose those two so I can see how much it's going up every year. Okay? So to find g, I'm going to take the new amount and I'm going to divide it by the old amount, or the y divided by the previous y. So I will be taking 122 and divide it by 116 on the calculator, and when you do that, you get about 1.05. I don't remember if it was exact or I rounded or not. But anyway, that's your g. So now we're going to write the equation y equals b times g to the x power. And now I'm going to let you do b. You're going to use this equation to tell me what it will be in 50 years.